Welcome everybody to this CAE presentation on radon. I'd like to thank Rebecca Coates from PropertECO doing the presentation this evening. Radon's something which has sort of bypassed the building industry lately, but there were some changes back in December last year, and there's other changes afoot, and so I think it's all important that we are here tonight. Before I hand over to Rebecca, I'd just like to say our chairman Michael regrets he can't make it tonight, so he's left me with the holding the chair. So welcome everybody on behalf of the West Midlands, and Rebecca, the floor is yours.
Thank you very much, Stephen. Good evening, everyone. Thank you for joining us after what I'm sure has been a busy day on a Monday, always is. I'm going to try and cover as much on radon as I can in an hour and leave you time for some questions. So I will be going fairly rapidly through the slides. I will make sure the slides, I think it's going to be recorded. I'll make sure everything's available. If I can send a copy of the PDF of the slides, for you to all have, happy for you to have that. So if I go through a bit quickly, you can see everything afterwards at your leisure. So my laptop is just catching up. So just a little bit about PropertECO. We're a national company. We're a small business. I was one of the founders back in 2011, and radon is all we do. We operate all over the country. I'm based in Bath. Our head office is up in Cheshire, and yeah, we cover the whole of the UK. We do everything to do with radon, from advice and training and consultancy, radon testing, mitigation, design and installation for existing buildings, and we do some consultancy on new build protection, radon protection for new builds on design. We don't get involved really with the site work for new build, but everything else, anything to do with radon, and we're happy to advise on it. So that's a little bit about us. This is what we're going to cover today. I've split it roughly into three sections. Firstly, what is radon and why should I care? Sometimes people have some funny ideas about what radon actually is and where it comes from and what it might do to you. How do I test for radon? When might I need to test for radon? How do I do that? Show you some of the tools you can use for that. And then if you find high levels in a building, how do you reduce those in existing buildings, and how can you protect new buildings from the outset from radon? And then we'll have a couple of case studies and hopefully some time for some questions at the end. So getting going, what is radon and why should I care? I hope that most of you in the building industry, construction industry, know that radon is a gas and that it comes from the ground. Some people I have saying, oh, is it something to do with computers and the gas they use, or in refrigerators? No, we're talking about a naturally radioactive gas that comes from the ground from the decomposition of uranium deposits. Uranium deposits are naturally present deep in the rocks and soils beneath us, and they've been there since the creation of the Earth. When uranium decays over millions of years, because uranium itself is radioactive, you get something called radium, which is a sort of solid silvery metal in its raw format. Radium used to be used, we had radium paint when you used to have the fluorescent dials and watches and aircraft dials, things like that. It was very handy because radium paint was fluorescent, so you could see it in the dark. Unfortunately, then scientists realised it was radioactive, so not really a good idea for people to be exposed to. So you'll only find those sorts of things in museums or antiques now. Things with radium paint on. Radium itself, that's a solid in the ground that continues to decay, and the next decay product from radium is radon, which is a gas, so it can move in the right conditions more readily through the ground. It can find its way through fissures and pathways, pores in the rocks and the soil to get up to surface level. The problem is that it can then accumulate inside buildings. The way that radon gets in, it can be a passive thing. It's just happened to come up and then it's finding its way through gaps and cracks in a building. But there's an active dynamic going on, which is all to do the differential air pressure between in our buildings and in the ground. Almost always in the UK, certainly, we have lower air pressure in buildings than we do in the ground. So the building is acting like a vacuum and drawing in gas coming from underneath it if there isn't some sort of gas-proof barrier there. The greater that pressure difference, the faster the rate at which the radon can be drawn in. There's almost always some radon in the soil beneath us, in varying concentrations. We can't see what's going on underneath the building. So anything that is there may be being drawn inside. via this process called advection, which is the movement of the gas from a point of high pressure to low pressure. And that's the important dynamic to bear in mind for when we come on to later, talking about the remedial options. It's all to do with reversing that pressure relationship between the building and the ground. So I said then there's almost always some radon in the ground. It just depends how much, and then how much ends up in the building. So we have got the source, the pathway, and then the receptor, if you're talking about traditionally with ground gases. With radon, the source, it's not coming from a man-made thing that we can say that's where it is. It's pretty much everywhere in varying concentrations. There are maps that are being produced by combination of geological data from the British Geological Survey and historical test data that the UK Health Security Agency hold. They pull that and they create some maps. Now, anyone eagle-eyed may have looked at this map and go, hang on, she's got the out-of-date map. She does. This map, I just wanted to put this up to reference. If anyone is still referring to this map, the yellow and brown map, this one has now been superseded. So this map came out in 2007. And was the map that we all used up until December 2022. So just over a year ago, this was what we used for 15 years. That has now been superseded by a new map, which covers England, Wales, Scotland, and Northern Ireland. And this is what the new map looks like. So as well as all the principalities being shown on the same map now, they have changed the colour scheme slightly. So we don't have the different shades of yellow through to brown now. It's all different shades of beige to brown, which is for accessibility reasons, apparently. It's easier, clearer to see. And one of the other big changes is that there's no white areas anymore. It's been a very subtle difference, that the areas where are now lower risk are coloured in cream rather than white, to get away from the feeling that people think that it means it's blank because it hasn't been mapped, or there's no data there. That's not the case, or that there is no risk. It just means it's lower risk in those areas. So the darker the colour on this map, the higher the probability that a building will have over a certain threshold of radon in it. It's not telling you that you get much higher levels of radon in that area. Sometimes that does follow, but it's based on frequency of number of buildings expected to be above a certain threshold. The darker the colour, the greater the probability. Nowhere in the country you could say there is no radon there. There is radon everywhere. It just varies. And this is based on probability. It is not definitive. The new maps that have come out, they are much more precise on the geology now. But it is still, if you use the free map online, it's based on the worst case probability for a 1 kilometre grid squared. So you can go online to www.ukradon.org, which is the UK Health Security Agency radon website. Click on maps. There's a free map there. You can put in your postcode and it will come up with the map like this. So I've used the CABE head office address in Northampton to show the map around there. And as you can see, there's various different colours all over this Midlands area, going from the cream, less than 1% probability. So that's classified as a non-affected area, or very low chance, right through to the darkest brown colours. I'm not sure if there's quite the darkest brown, centre of Northampton, where there's a greater than 30% probability, and sort of Corby area, greater than 30% chance. So more than 1 in 3 properties there would be expected to have a high level of radon. And then all the varying shades in between. So those are the maps you need to be looking at now. Not the old yellow ones. So this is based on a 1 kilometre grid square. If you want a more precise result, you can pay something like £3.80 and get a postcode specific probability. Again, on a building, that will be specific to the building. Again, it's not going to tell you what your radon level is in the building. The only way to do that is with testing, which I'm going to come on to. This is just to show what the probability or the likelihood is that that building will be affected. As I said, those maps changed just over a year ago, and there were some areas where there hasn't really been much change, but there are some areas where the risk banding has changed quite significantly. Just before the maps came out, we were doing a bit of work for a national client, and we looked at about 850 of their properties. It's a hospitality industry, well-known name, something in every town across the UK pretty much. We'd looked at 850 of their properties and classified them into which affected area band were they in. We then redid that exercise with the new data set, and based on those 850 addresses across the whole UK, we found that there was about 13% that previously were in the less than 1% risk band, which were now in 1% or higher risk. So as soon as the risk is 1% or higher, that is a designated radon affected area. And some of them had gone up. They weren't just, you know, snuck into the first risk band. They were quite considerably up in sort of 10 to 30% risk. From previously, it was thought there was a less than 1% chance there. 2% had gone out. So the other way, it was deemed that they were probably no longer at risk. 5% had gone up at least one band. 2% gone down at least one band, and 78% there was no change. But the important ones are those 13% that had moved into an affected area. So if someone had done a risk assessment previously, checked the map before and said it's fine, we're in a lower risk area, we don't need to do anything further, it's really important that you check again now against the new map to check you haven't actually had your risk estimate changed. And just an example, I happen to have a screenshot of the Canterbury area from a seminar like this that I had done before the maps changed. And bear in mind that the colour scheme has changed, so it's not quite as dramatic as it looks. But if you look here, around the Canterbury area, old map, this was so less than 1% risk in this white area, 1 to 3% risk in Canterbury around here, and some higher risk over here. But on the new map, the risk is south of Canterbury here is now 10 to 30% risk area, whereas previously that was 1 to 3% risk. So the estimated number of properties there has gone up, that would be affected has gone up significantly. So what I would say is the maps are always going to be under revision. We don't know what will come in the next set of maps when things get more precise. They are always only going to be an estimate and guidance. If it was my house, if I was buying a house, building a house, I would always want it tested, because you spend a lot of time there. And to base that decision as to are you going to be affected by something long term on what a map predicts, how many houses, even if it's less than 1 in 100, if that does happen to be, if it's 1 in 200 and your house is that one house that is affected, you want to know about it. So that would be what my stance would be on it, because testing, as we'll come on to, is not hugely expensive. Special note on buildings with basements. UK Health Security Agency, previously were called Public Health England, have been saying for years now high radon concentrations can be found in basements anywhere in the country regardless of affected area status. And that's because if you think about a basement, we've got up to 5 times the surface area in contact with the ground through which the gas can permeate. We've also usually in basements got the conditions, lower air pressure, less ventilation, ideal conditions for the gas to be drawn in. So it doesn't matter where you are in the country, if your building's got a basement, you should proceed with whatever decisions you're making as if it was in one of the affected area categories, even if it's in a cream area on the map. And why should you do that? Why is it important? Who cares about radon? We can't see it, we can't smell it, we can't taste it. There's no way of knowing how much is in your building unless you've done a test for it. It's not affecting you that you know perceptibly day to day. It wouldn't give you a headache, anything like that. The only thing that is being definitively linked with long-term exposure to high levels of radon is an increased risk of lung cancer. It is the second leading cause of lung cancer worldwide after smoking, obviously. In the UK, it's believed to be responsible for over 1,100 deaths every year. And it's the biggest radiation source that most people will get, unless you are a classified worker in some sort of nuclear industry when it's being monitored very closely, what your radiation doses are. Most people clock up the most amount of radiation they're going to be exposed to over their lifetimes just by living at home, at work, in a certain level of radon. You will be exposed to a certain amount at home, everywhere, in every building, and that leads to the biggest radiation source that most people get. So that's why it's important that we know how much are we being exposed to, and no one wants to have this unnecessarily, but that's what we could be getting at the moment if you haven't tested your buildings. Got one slide here just to say that unfortunately the way that we are designing buildings these days and making changes to existing buildings for energy conservation purposes is actually making radon levels worse unless radon is specifically being addressed in that project. So saving the planet is outweighing saving our health and protecting our health at the moment in a way. So there's a couple of studies here. One that was published in the BMJ. This is quite old now, this one. This was a modelling study that looked at, okay, if we carry on doing things as we are doing now, the mean indoor radon concentration is going to increase by more than 56% every year. And a more recent one that they did at Imperial College, I believe this one was, this was retrospectively looking at buildings that had been tested for radon about 30 years ago. They had actual test results, data on what was in the building at the time. They've then gone back to those same buildings and said to the homeowners, okay, what's changed? Have you had double glazing put in? Have you done loft insulation, wall insulation? And then they were tested for radon again. And they looked at all these things and they found that all those things increased the mean indoor radon concentration, double glazing being the most significant at a 67% increase on average, which is quite an increase. Obviously, if you're starting with a very low radon level and you increase it by 67%, it's still not going to be that high. But if you have a sort of borderline level previously and thought, oh, that's fine, we're under the level, we need to think about it. But if you've then increased it by nearly 70%, it is then at the level where we need to do something. So always bear that in mind if you're advising clients on changing the windows, upgrading energy efficiency through insulation or something that's going to change the ventilation or the insulation properties of the building. Always think about the knock-on effect it may be having on the indoor air quality, which includes radon. So how much is too much? I've talked there about increasing the average radon level. So in the UK, we measure radon in a unit called becquerels, which is expressed as becquerels per cubic metre of air. Outside in the fresh air, anywhere in the UK, you're likely to have background levels of about 4 becquerels. So even outside, it's very rarely 0. So whenever you do any radon testing, you're pretty much never going to get a result that says 0. That's not a problem. The average UK home is said to have about 20 becquerels in. That figure's been bandied about since I've been in the industry. And I would think it's probably actually higher than that for the reasons I was just talking about on the previous slide. So I'd say between 20 and 25 is probably the average level in the UK now. And then we've got things called action levels and target levels. So the action level for homes is 200 becquerels, so about 10 times the average level we'd expect to find in the UK. And that is the point at which the government have advised via guidance from the UK Health Security Agency that in a residential setting, you should do something about it. And we'll talk about when that becomes you must do something about it a bit later. Since 2010, we've also had a target level of 100 becquerels, which is a bit confusing, but basically the advice is if your level in a home is over 200, you should definitely do something about it. If it's between 100 and 200, you should strongly consider doing something, particularly if you've got smokers or ex-smokers in the household. By smoking or being an ex-smoker, your risk of lung cancer is that much higher, your baseline risk. If you then add radon exposure into the mix, there's a synergistic effect, so your risk increases quite considerably. I think in the future, we may well end up having our action level reduced to 100 becquerels. The reason why that came about in the first place in 2010 is the World Health Organization issued guidance that said countries should set they call it their reference level at 100 becquerels where possible. There's no reason in the UK why our action level couldn't be 100 becquerels compared to other parts of the world. Our natural levels of radiation or our average levels of radon are much lower than some parts of Scandinavia, for example. They've got much higher levels. So I wouldn't be surprised if at some point in the future we didn't see our action level dropping. So that's for homes, and mainly that's recommendations unless it's rented accommodation, which we'll come on to. Workplaces, the action level is 300 becquerels, and this is enforceable, so we'll talk about that in a minute. These levels that I'm talking about here are all expressed as annual average levels. So, I haven't got the slide there. So radon levels do fluctuate throughout the year, highest in the winter, lowest in the summer. Whenever you do any testing, the lab will give you what your actual result is and what your estimated annual average level is. And it's the annual average that you need to compare to these action levels. So I said there that residential action level 200 becquerels. Above that point, you should do something about it. Average level in your house, usually across the UK, is about 20 becquerels. What does that mean? No one really understands what 20 becquerels of radon means to you, to your family, to your health. This hopefully will put it into perspective so you can understand, okay, this is something I wouldn't want to be exposed to, or my clients wouldn't want to be exposed to. So if you spent 8 hours per day in a building with, on average, 200 becquerels of radon throughout the year, your lungs would receive the equivalent equivalent radiation dose to if you'd had 112 chest x-rays in that year. So that's the action level at which it's recommended you do something about it. And that's the equivalent of going to the hospital every 3 days and asking for a chest x-ray. Don't think many doctors would give that to you. Don't think anyone would really want that unless it was absolutely necessary. But that's the level of radiation you could be getting. If you haven't done any testing in your house, your office, you have no idea how much radiation your lungs are being exposed to. And that is quite common to find those sorts of levels. There's a table here. So if you do any testing, this will be on the slides when you get them afterwards. You can see roughly how many chest x-rays have we been getting. And this is these are based on 8-hour exposures and per person. It's not shared between the occupants. You might look at that and say, well, I've got 25,000 on there. Surely radon can't get that high. It can. Highest levels we've dealt with as a company, I know of 2 properties we've had that have had about 18,000 becquerels in. One, a commercial property in Northamptonshire, and one, a very ordinary looking from the outside mid-terrace cottage in Devon. With 18,000 becquerels in. So huge levels, and fairly frequently we're dealing with properties in the thousands, and obviously regularly with anything from 100 becquerels up as well. But it's not uncommon for levels to be well over 1,000. If anyone's a smoker as well and you think, oh, well, that's one thing that's damaging my lungs, this is another. So the risk, roughly, if you spent 8 hours per day, 200 becquerels of radon, the damage you've done to your lungs is about equivalent to if you'd smoked 5.5 cigarettes in that same period. But if you have smoked those cigarettes and you've had the radiation from radon as well, then unfortunately it's more than the cumulative effect, and there's this synergistic effect, so the damage is even worse. So the message is, if you're in a radon affected area, definitely test. If you smoke, try and quit smoking. You do not want the combination of both. And I include this slide because I think a lot of people now, we're aware of carbon monoxide poisoning because there are stories in the press. There's someone to blame if someone hasn't serviced the boiler fault, if there's been a fault with the boiler and someone hasn't serviced it properly. Everyone knows to go to B&Q and get a carbon monoxide alarm. But statistically, I think it's about 40 people a year, still, it's 40 too many, are affected by carbon monoxide poisoning or dying. Whereas we've got over 1,000, over 1,100 from radon-induced lung cancer. But because it's a long-term thing and it's not, there's a body on the floor tomorrow to put in the local paper, it doesn't receive the attention that some other things do. But it should do. And I think tides are changing, and we certainly, year on year, we're always getting busier and awareness is growing. And that's why I do a lot of these things, to try and spread more awareness through professionals as well. So whose responsibility is it to do anything about radon? I've said it's natural, it's in the ground. Whose responsibility is it that it's there and how to get rid of it? There are different responsibilities, whether you're a homeowner, an employer, and a landlord. I'm going to go through all of those in a minute, but because a lot of it is going to relate to when you have to test, I thought I'd just talk a bit about testing first. So how do I test for radon? Easiest way to do radon testing is with, I've got one here, passive radon detectors. They are just small sort of domes of plastic. They're passive, there's no on-off switches or flashing lights or measurements on these at all. How they work is inside there's a lens of highly sensitive clear plastic. This lets a controlled amount of air through the detector. They get left in place in a property for a period of time, usually 3 months. Put them in place, leave them there. They then come back to the lab for analysis. The lab opens it up, looks at that lens inside under a very powerful microscope, and effectively they count the dots, more dots on it. So it's called a track etch detector. So the radiation makes the damage. The more dots on it or damage, the higher the radon level over that test period. Very simple, but highly effective and the most cost-effective way to do radon testing. It's recommended that you test for a 3-month period because, as I said before, radon levels are constantly fluctuating. This is approximately how they fluctuate throughout the year. In a standard building, in a standard weather year, we have almost twice as high radon levels in the middle of winter than we do in the middle of summer. So we're sort of coming out of that peak season now, really sort of November to February, kind of peak times. And then the summer, July, August is when radon levels are usually at their lowest. You can test at any time of year. As I said, the lab applies what they call a seasonal correction factor to the raw results. So if you do a 3-month test starting in November, your raw results will be higher than what your estimated annual average is. If you do it in the middle of summer, it's the other way around. If I was doing testing, I would test ideally over the winter months or the spring, ideally not right in the middle of summer, because you've got less data effectively that you're basing your annual estimate on. But it can be done at any time of year. We do also offer 10-day screening tests. They are very much a snapshot of what the radon level was like over that 10-day period. We can't apply a seasonal correction factor because there's not enough confidence in the result to do that. And it is very much a snapshot of that 10-day period. And it could do, if you do 10 days back to back, they can be quite different depending on what's happening with the weather, how changeable it is. But it can give an idea, if you're in the process of buying or selling a house, it can give you an idea if there's going to be a very big problem. Certainly, it usually would flag that up. So when you're doing testing, if you've got a standard house, how many detectors do you use? Where do you put them? Usually we put one in a ground floor living area and one in a first floor bedroom. So you're testing the areas with the highest occupation. In a commercial building, how many do you need? It depends on the overall layout and size of the building. This is guidance that comes from UK Health Security Agency on how many to use. Things like small shops, offices, schools, it's usually about between 1 in every 2 and every 3 ground floor rooms. We always test some first floor rooms as well. If it's big, large warehouses, open plan offices, then it would be lower density of detectors being placed. Basements, you need to put 1 detector in each area, each separate area, because it can be quite different in basements. But we're always happy to advise on locations if anyone wants to do any testing. People send me floor plans and I can put on dots and say I would test this room, this room, this room. So just what does that look like in practice? Local authority, we do a lot of testing for different local authorities and all their different types of buildings. So just a few different types. So say a little small local library might need 3 detectors, fire station needed 2, and a primary school had about 14 in it. There's the sort of thing on a floor plan that just shows you the density. This is a school building where we would typically put detectors where those green dots are, spread across the footprint of the building. To make sure there aren't any areas that we're not testing. But yeah, you don't need to test every room initially. Practical points if you're doing any radon testing. So we go out and put these detectors in and pick them up, or you can buy them online, order them from us. They can be sent in the post. They all have a unique serial number on them, so make sure you know exactly where they've been placed. We recommend using their cable ties. They've all got a loop on the top. Physically attach it with a cable tie to something, because 3 months is quite a long time to leave something and expect it to still be there when you come back. Make sure you log where the detector is, so which room have you put it in. Ideally mark that on a floor plan and don't just say so and so's office, because in 5 years time, if you're coming to look at this again, no one knows who they were, or they moved office at some point and you don't know which one was it that was actually tested. So ideally mark areas on floor plans, and they do need to come back to the lab for analysis. So within a couple of days of the end date of the testing, we really need them back in the lab to ensure that the results are accurate. So that's the cheapest, easiest way of doing testing over large buildings, or if you've got big stock. We sell these, they're £16.50 each per detector. And that includes the detector and all the lab work and the results reporting. So yes, if you've got to do volume, that does add up, but per detector, if you're talking about a house, it's less than £50 to test your house for radon, and that's the only way to know if you've got high levels. We do also there are now available different digital monitors that will give you a result on the screen, so you don't have to send it back to a lab. None of these are instant readings. So again, radon levels fluctuate. The detectors have to calibrate and calculate their averages. So you can put them on and they will start showing you results, but we would never place any real reliance on what that is showing you until at least a week of having constant results on there. So we've got a couple of fairly new ones here. This one's called the Eco Blue in the middle. And it is a lot more sensitive than the one on the left. There is a Corentium device, which have been around for quite a while now. They were sort of the first consumer grade digital radon monitor that you could get. and they do have their place. These ones here are a lot more sensitive now, so these are the ones we tend to recommend to clients, these two. The one on the right has Wi-Fi enabled, so you can put that, so the monitor itself doesn't show you a reading on it, it all connects up to an app, so you can monitor remotely from anywhere in the world, as long as you've got Wi-Fi, what is the radon concentration in that building at the moment. So that's really useful for facilities managers, things like that, who might be managing a portfolio without having to go and put in the detectors and pick them up, get them posted back. They can see on an app what the radon level is. And that's what it looks like. And it also shows you the fluctuations. So if you want to get techie about it, you can see, oh, when our ventilation system comes on, what happens? Do the radon levels go up? Do they go down? Is it overnight that they're higher? When we're not occupied? All those sorts of things. You can actually see that data on that one. That's called the Eco Cube. So a little bit on when you have to do anything, who does. So what are the legal obligations? What's best practice for different stakeholders here? So for your own reference, or if you're advising any clients buying or selling homes, for homeowners, it is completely up to you if you want to test your house for radon. It's completely up to you if you test your house and you find you've got high levels, whether you want to do anything about it. The only situation it becomes an issue potentially is in conveyancing. If you're trying to sell your house, if it is located in a radon affected area, so anywhere on that map that's not cream, that will be flagged on the surveys, the local searches. The surveyor's report will say, or the environmental report will say, oh, it's in a 1 to 3% risk area, or 5 to 10, whatever. And then people tend to go on Google and say, oh, what's this? And then get worried. If you do any testing, you have to disclose the test results, though, to the buyer, potential buyer. And you also have to disclose if you've done any remedial works as well. I would always recommend, if you're thinking of selling your house and you're in a radon affected area, test first, because chances are someone's going to ask you to do the test anyway. You can do the test then without it slowing down the process. And chances always are, even in the highest risk areas, you probably won't have a problem. The probability is. And then you can just head all that off and have the results ready to go. Yeah, we've already done it, not an issue. So that would always be my advice. If you're talking about rented residential accommodation, radon's covered under the Housing Health and Safety Rating System, which rates different sorts of hazards into bands, with band A being the most serious hazard. Landlords have to test for radon. They should test for radon. Many don't know that they're meant to test for radon, but they should. Once it gets above band A, it's sort of classified as the most, above 800 becquerels, it's in band A, the most serious sorts of hazard you could have. Anything above the action level will be band C, and that is a category 1 hazard, it's called. So a category 1 hazard, anything in A, B or C, the local authority should be issuing improvement notices to the landlord to do something about it. This is, so the HHSRS guidance document is where it says you need, if the dwelling's in an affected area, the only way to determine whether or not there's affected health is by measurement. So that is saying you need to do a radon test. But I'm pretty sure the percentage of landlords, certainly private landlords, who've actually done any radon testing is very minimal. But hopefully that will change in time. And it also gets caught under all of these other legislation for rented accommodation now as well. Employers is where there has been action and where the majority of our work comes from these days. We're very busy in the commercial sector. We do residential and commercial, but a lot of our work is commercial now. Employers have a duty of care. They have to protect health and safety of their employees and anyone else using the building. Every single workplace in the UK should have a radon risk assessment. Could be very simple, look like this. Just say, we've looked at the map, we're in this percentage risk area. Do we have a basement? Yes, no. Based on that, we might be at risk, so we should do some testing. Or based on that, we're at very low risk, we're in a less than 1% risk area, we don't have a basement, so we don't need to do anything further now, but we will review again in 5 years, check the map, see if anything's changed. So every employer should have something like this in their risk assessments. We're getting there, more and more are, but still percentage-wise, probably fairly few. So what HSE say is that if a workplace has a below ground area, so if it's a basement anywhere in the building and it's located anywhere in the country, or if it is in a designated radon affected area, so anywhere where the risk is more than 1%, so anywhere on that map that's not cream, you need to do radon testing. The employer needs to do radon testing. If the results come back as less than 300 becquerels, that's the annual average, that's fine. Don't have to do anything else. You just record that, and you will be advised to retest at some point in the future. It will be at least once every 10 years, depending what the level is. If it was only marginal, it might be every 2 years or every 5 years, but at most every 10 years. And a lot of employers, we do it, and then we think, great, you can park that now for 10 years. It's not an expense that someone has to do necessarily every year. If the results come back at over 300 becquerels, though, then IRR 17, so the Ionising Radiations Regulations 2017, come into play. This is the same regulations that applies to, you know, this sort of thing, nuclear power stations, the sort of thing you think of when you think of radiation and workplace. If you have an office or a shop or a school with over 300 becquerels of radon, it's a workplace working with radiation. The employers are working with radiation, therefore there's certain red tape and things that you have to do. Firstly, you have to appoint a radiation protection advisor who will immediately do some calculations of dose, so radiation dose, and that will depend on the occupancy level. So they'll say how many people spend how many hours in this room that we now know has X amount of radon in, and they will then say, right, they're getting too much or too high a dose of radiation, so you need to limit it potentially to this many hours a day or this many hours a week, depending what the radon level is. You have to notify HSE via their online portal. And then you have to do something long term to reduce that exposure, which might be restricting access. If it's a basement store and you know people don't really need to go in there that often, and if you can put procedures in place to ensure you know who's accessing there, there's a key and only one person has the key and they have to sign it in and out, then that's fine. Most workplaces, though, if you find there's an area with high levels of radon in, they need to do something, some sort of engineered control that reduces the radon level, which we'll talk about in a second. You must then retest to prove the levels come down, and then that's all fine. And you must then obviously maintain systems and retest, usually annually at that stage. And you do also have a duty to inform your employees if you find high levels. So there's a flow chart there. You'll have this all when you get the slides afterwards, just talks through the process of what we've done there. I've got some slides here that have come from a presentation that the Chief Radiation Inspector at HSE gave, the Principal Radiation Inspector, at an event I went to, because there has now been some action by HSE on radon for the first time ever. So this is going back about 2 years now. HSE became aware of a school in Bath and North East Somerset with high radon levels that hadn't done what they should have done. Because the levels were so high and the HSE were so concerned about this, they actually decided to trial something proactive, which they hadn't done before, and they wrote to every single school in Bath and North East Somerset and said, where's your radon risk assessment? If you haven't got one, they were given 4 months to get the testing done and get the results to them. And they did. So I'm based in Bath, as I said at the start. My phone started ringing off the hook with all these schools, and I thought, what's going on? Anyway, we did a lot of testing. Some others did testing as well. And all these schools eventually got tested, and it actually ended up being 10 still had levels over 300 becquerels. So those schools today probably still have had high levels if HSE hadn't proactively gone and said, where's your radon risk assessment? Why haven't you done testing? Despite me, I do try and do some marketing and outreach, business development, and email these sorts of people and say, oh, have you done your radon testing? And they ignore me. But when HSE come knocking, people do what's necessary. Anyway, so those schools were remediated. We did a lot of the work there. And HSE have now decided they're actually consulting at the moment, I think it might have finished now, on what they should do. How should they change their policies? How can they be more proactive rather than just being reactive on this? And I think that really showed that all they had to do, they sent out some emails and said, where's your radon risk assessment? And they discovered those schools that had high levels, that if they hadn't done that, and the guidance is there, people just don't necessarily know. I don't think they're deliberately not following it. They just don't know that they're meant to be doing their radon risk assessments. And if HSE go and put it under their nose, then it creates action. So what happened in that one I'll come on to in a second, but this was something that the guy from HSE said, and I thought, wow, that really does show the scale of the problem. So he said, if we extrapolate those results from Bath and North East Somerset nationally, he said there's about 32,000 schools across the UK. If you look at the maps, roughly about 10% would be classified as in affected areas. And then if we say conservatively, maybe 200 pupils per school. Some schools have got a lot higher numbers than that now. And in Bath, it was 17% of those ones that were in the affected area ended up having high levels. And Bath has got some of the sort of lower risk areas, some of the very high areas, a mix. So it's fairly representative. But if we work that through, as of today, we've probably still got more than 100,000 school children sat in high levels of radon at school that they don't know about, the teachers don't know about, the parents certainly don't know about, because no one's done the radon testing. As well as those children, there are the staff, there's the children who've been through the school and left, there's all the other support workers at school being exposed to these high levels of radiation that no one knows about. Someone should know about it, but the testing hasn't been done. So that's why things are starting to change, the message is getting out there, but it's really important we do what we can in educating people. This is what happened. So with that very first school that kicked off that whole campaign in Bath, it went to court. The very first prosecution there's ever been about radon was this school. They did get fined, they were prosecuted, the fine was £50,000, down from a starting point much higher than that, but there were mitigating circumstances because they have, to be fair to them, they've done an awful lot of work since then to put it right and to get it right going forward. But anyway, that happened. There was all sorts of headlines about this boarding school having unintentionally exposed staff and pupils to some very high levels of radon over a period of time. So when it hits the press, when HSE start doing that, that's when people start taking action. And yeah, we have been very busy in the education sector. I'm waiting to see what HSE do next, which sector are they going to target next, but it does create results. So let's say you've done some radon testing, you've found high levels in the building, what do you do about it? So this is the sort of practical bit, and I know I'm going to run out of time, so I'm trying to go as quickly as I can here. So as I said before, we talk about pressure. We usually don't test every room in a building to start with. So the first thing we might do, if it's a big building, we might do some grab sampling. We've got this bit of kit that takes, it's a 6-minute radon sample. We would never ever come to site and say, oh, we can do an instant radon risk assessment for you and tell you what your radon levels are in 6 minutes. And if anyone ever offers to do that, they're a cowboy, they don't know what they're talking about, because radon levels, if you came back later in the afternoon, they could be completely different. What this does is it allows us to build a very quick pattern of results. Just to do, we sort of benchmark against the long-term results if we know we've got a high level in one room, and then we say, okay, but is the neighbouring room also high, or is that higher, or is it lower? And it just paints a picture so we know how much of the building is actually affected, or is it limited to a very small environment in one area particularly. So we might do that if it's a bigger building, and then we look at the best way of tackling it. And there's two main ways to deal with radon in existing buildings, both to do with changing that pressure differential. So we've got a radon sump, which is about creating a negative pressure under the building. And then we've got positive pressure systems, otherwise known as positive input ventilation, which is about very slightly increasing the pressure inside the building. So I'll just talk about those a bit more. So a radon sump effectively is create a small hole under the building to become the low point of pressure. The gas will be attracted towards that low point of pressure where it can accumulate, and then we put in some pipe work with a fan to make sure we're exhausting it away from the building to where we want it to go. Normally with existing buildings, we call that a mini sump. So we core drill with a diamond drill from outside the building. We're not ripping up floors. Normally it's all from outside. The only thing we need to come inside for is the electrics, and it's all done outside. And to install something like that, a standard sump like that on a 2-story building would take us around about a day or less than a day to get that in. So it's not disruptive building work, but they are highly effective. Obviously you need to make sure where it's venting is well away from any opening doors or windows. So usually it means taking it up to above eaves level. This is what it looks like. So we'll come along with core drill. Depends if there's sort of flower bed here or tarmac or flagstones to lift, get down. So we're drilling beneath the floor level to get into the hardcore fill beneath the floor to create the sump. Pipe work goes in, fan on the wall, and then exhaust pipe. We do now have fans, black and white fans. We use the radon-away fans, which come from the States. They are designed specifically for use with radon sump systems. There are other fans that people can use that are sort of general ventilation fans, but either they're not IP rated for outdoors, or even if they are, they're not designed to have soil gas passing through them, which has high humidity levels in. So the motors can corrode or go wrong. These ones are designed specifically for radon. They come with guarantees. So yeah, and they're pretty good. Not too aesthetically displeasing, fairly neat and compact. And that's the sort of thing that would look like on a domestic property. Couple on schools here, you'll see the fans are higher up here. Usually we try and put the fans as low as possible to minimize any noise. If there is noise with a sump system, it's not the fan. The fans themselves are very quiet running. It's that air movement and the air being sucked up from the ground to the bottom of the fan. So the shorter the distance it is from the ground to the fan, the less chance there is of any noise. With schools, we don't want fans low down. People are going to kick a football on or try and climb on. So we put them higher up. Very occasionally we have to do internal sumps. So this was a school that had high levels. We tried it with the mini sumps. One side of the building, they weren't effective. There was glass all on the other sides, couldn't do anything, couldn't get to it. So we had to do this. So this is pipe work with then preformed sump boxes. So like an old fashioned milk crate, effectively like a plastic void, bit of formwork. Connected with pipework, and we actually put 3 along this corridor here, built into the floor, capped over, put the concrete back on the floor. You wouldn't know it was under there after we'd finished, and that did work very successfully, that one. I can count on one hand the number of times I've done internal sumps like that in the last 15 years in commercial buildings, pretty much. Usually we can always do it, and certainly with residential buildings, almost always from outside with the mini sumps. If you've got a large commercial building, it might look something like this, multiple sumps needed to cover the whole footprint of the building. Positive pressure systems work slightly differently by raising the internal air pressure in the building. Firstly, they will dilute what's in there and displace radon, but then they give you that slightly higher air pressure inside, so it's inhibiting that advection process. Not as much is going to be drawn in. They can be really effective for lower levels of radon, so anything above about 300 becquerels. If it was in a domestic situation, we'd be looking at using a sump. Less than that, you might try positive pressure. Positive pressure systems do come with other side benefits. They'll improve your relative humidity, so you won't get condensation on the windows, mold growth, which is what the units are traditionally used for as well. So there are some side effect benefits of using PIV when it is an option, but if you've got higher radon levels, usually we go for a sump system or a combination of the two. That's the sort of thing it looks like up in the roof, or there are through the wall versions, so that's got a louvered vent on the outside of that external wall, drawing the air into the back of the unit. And then that's a more industrial one if you need a larger system. We do a lot of work in the banking sector. They've often got basements. The vaults can create the ideal conditions for radon to accumulate, low pressure, sealed up. This one had about 5,500 becquerels in that strong room vault there, but also high levels throughout the rest of the basement. So it was a combination of sump and positive pressure there. So in a situation like this, where you've got a fairly airtight room, positive pressure can successfully be used, even at levels like 5,500 becquerels. But typically in a standard building, we wouldn't be using positive pressure for those sorts of levels. It would be a sump. Basements come with their own challenges. If you think about how I've described a sump being put a small hole under the building to collect the radon in, unfortunately a basement is like a very large radon sump that we're then expecting people to go and live and work inside once we've made it all nice and fancy, like a media room or something with gym. There are challenges with basements because we can't just put a sump in the floor, because A, there might be issues with the water table, B, you don't know that's the lowest point of pressure, the gas might be coming through the walls, nowhere near where your sump is in the floor. It won't necessarily work, and we don't often put sumps in basement floors. We deal with it with either air management with positive pressure, or we have a system that my former colleague developed called the radvantage system, which makes use of cavity drain membranes, which are normally used for basement waterproofing, the sort of dimpled HDPE plastic membrane. which lines the inside of the walls and the floor. What that gives you is an air gap behind the membrane where the gas can come through the walls, accumulate in that air gap. We then install the inline radon exhaust fan that we would use on a sump to draw the gas away from behind the membrane. And you can have all the waterproofing perimeter drainage in as well if you need it. And then also we put positive pressure into the room just to make sure the air pressure is higher in the room, because these systems are usually fixed with plugs on the wall. They're not going to be airtight, so we need to make sure the gas isn't going to be drawn through any of those defects there. But that can be really effective, that system. And even if you haven't got a full basement, we can tap in a mini sump, so put some pipe work under the solid floor area of the building into the back of the membrane and then use that system. I'm going to talk about new build. I want to leave some time for questions. I hope I'm not going to lose anyone from going on too long. But so BRE came out with new guidance on new build radon protection just under a year ago. It was May 2023. And this was following the revision of the maps that came out in 2022. New guidance. So it's BR211, and this is where building regulations part C points you towards. There have been several versions of BR211 dating back till 1991. I couldn't find a picture of anything on the 99 version, and then 2007, 2015, and now we've got 2023. All of these have had various different guidance in. Some of them have had maps in saying where you need to put the protection in, and different changes. We now have, there isn't a different set of maps. So the previous version had, you might have seen there were maps that were white, light grey or dark grey, which said where you need to do no protection, basic protection or full protection. They were actually still referenced in the original version that came out in May, and I queried, where are the maps? And they said, that's an error, we're not using maps anymore. Specific maps for new build, we're referring people back to the UK HSA maps. So whenever they get updated, we don't have to update the separate maps as well. Unfortunately, we've still got a silly situation in England and Wales, which is not replicated in Scotland and Northern Ireland. But in England and Wales, the building regulations do not require you to put any radon protection in until you are in a 3 to 5% or higher risk category. So basic protection here is a membrane, gas-proof membrane. Full protection is a membrane plus some form of, so you can have active mitigation in the future. So either suspended block and beam floor or an inbuilt sump system capped off. In Scotland, Northern Ireland, as soon as you're in a radon affected area, so more than 1% risk, you need to put basic protection in. In England and Wales, that does not trigger until you get to the 3 to 5% risk area, which is crazy because you could put up a new building in an area, it's 1 to 3% risk on the map. Builder says don't have to put any radon protection in, building control signs that off. Yep, they're doing what they need to. First occupier is an employer, they have to do radon testing legally, they do their radon test, they may find they've got a problem, they then have to start drilling holes in it and put remedial systems in a brand new building in a known radon affected area. But that's where we are at the moment in England and Wales. So you do need to do basic radon protection in the 3 to 5%, 5 to 10% risk areas, and then full protection in the 10% and higher areas. And this is what it looks like. So this is basic radon protection, a gas-proof membrane. So it's the radon version of the membrane. It's not the foil-backed one. So there's different thicknesses of membranes. The ones with the foil on the back are for other sort of VOCs, carbon monoxide. The radon one does not have foil on, but it does need to be a suitable material to withstand site conditions. Ideally one that can be heat welded, so the joints are not taped, and make sure that any service inlets use top hats around those to protect those properly. Do not sign off anything, or hopefully you won't see anything like this on a building site, but this is the sort of thing that we know does happen. Someone might get away with that if that was a DPM. For radon, that's not going to cut it. The gas will find its way through that straight away once you have that advection suction process going on. But those are the sorts of failures that are seen in new build protection for radon, which is why even new buildings have to be tested for radon. You can't assume just because it's new, it won't have radon in. Small defects make the barrier useless. Next time you have a takeaway coffee, have a look on the lid, and you'll see there's a big hole for drinking the liquid to get your coffee out, and then 1 or 2, sometimes there's 2, tiny little pinpricks. Some people might think, oh, is that to let the steam out? No, it is to do with the pressure. It's all physics. When you drink the liquid out of the big hole, the compensating amount of air goes into the cup through the small holes to mean that your cup doesn't depressurize, so it doesn't squash in your hand. So the same volume of liquid coming out through the big hole, you only need 1 or 2 tiny pinpricks to let the same amount of air come through. And that is the attention to detail you need when getting a gas barrier gasproof. And what is waterproof is not necessarily gasproof. It needs complete attention to detail on a building site in the UK where it's windy and wet. So it is hard to do, but it does need to be perfect, and otherwise there's no point in doing it. There are now verification services out there where you can get your membrane verified by an independent validator. Full protection, you need to put that membrane in as well, plus have some provision for providing active mitigation or mechanical ventilation at some point in the future if it's needed. So that would either be ventilated beam and block floors, something you can put fans on to either pressurize or extract from that floor void, or preformed sumps like I showed you when we had to cut up the corridor in the floor in the school, put those in and cap them off, ready to be used if necessary, so activated with the pipework and the fan on the outside. The only way to know whether you need to use these is to do testing on completion. So it's really important that that is done once the building is occupied. So I've got a couple of case studies and then 5 minutes for questions. So some schools, we did testing for a multi-academy trust in a lot of their schools. Out of about 30 schools, they had 3 that needed some remedial works. I've put the results on the floor plan of one of these schools here, a secondary school, just so you can see the variation even on one site and why we test as many rooms as we do. So all the green ones are nice and low, orange ones are getting a bit higher, but then you'll see in the middle here, 2,657 becquerels. There we've got over 300 here, and then another room right in the middle of this science block with 2,000 becquerels in. If we hadn't tested as many rooms as we had, or with our knowledge of knowing which rooms might have been likely, so this one over here with the 2,000 was slightly below ground level, so we knew it had an earth retaining wall. That rings alarm bells with us, say there's more chance there, treat it like a basement, so we tested that room. Reasons why they might be higher, but if we hadn't tested that many, we wouldn't have known. We could quite easily have missed those rooms. Across this trust, we dealt with a mixture of sumps and positive pressure systems. Then I've got a residential property here. The reason why I want to show you this one is it had an extension put on it. The new owners did some testing in the original part of the building and in the extension, and they found very similar levels. Fortunately, the builder had followed the building regs and put in a preformed sump, capped off, ready to be used if needed. Unfortunately, hadn't really thought, oh, what if we actually need to use this? And he'd capped it off right underneath a window. We did then need to use this. So unfortunately, rather being nice and neat and being able to just put the vertical pipe with the fan in, we didn't then have to take it. So it's this one over here, had to take it across the building and then up. So it didn't look quite as neat as it could have done. So if you come across plans, get them put on your desk with things like that on, just have a look where the windows are and where they're planning to cap these things off, and if possible move it so it's not right beneath a window or a door. Anyway, those sumps, and they needed a sump on the existing bit as well, those levels came down nice and low. And then I've got one here to finish with a cellar. When we were called, we were told, oh, we've got over 2,000 becquerels in the cellar. We've already had someone come in to try and deal with it. They seem to have made things worse. And we said, well, what have they done? And what they'd done is they'd put an extract fan in the basement, with the thinking being, there's gas in there, I want to get rid of it, I'm going to extract it, without understanding the mechanics of what's going on. Putting an extract fan in, all it was doing is sucking more in, lowering the pressure, sucking more in, creating a bigger problem. We can't get away from using extract fans in bathrooms and kitchens. We need to do that. They're low powered, it doesn't really matter having them on, but never put one in, a high powered one, for the purpose of trying to reduce radon levels, because all you'll do is make the matter worse. When we switched that off, the levels went down to about 1,000. So they still had a significant problem, but not as bad as they had for when this non-expert had tried to help. We then installed the system, the Radvantage system with the membrane. and the correct ventilation techniques on there, and the levels came down to 8 becquerels, and they had this nice dry home gym that they could use. So I know I've rattled through those last few bits there. I hope I haven't glossed over anything that anyone was hoping to hear, but hopefully you've now got a good idea of the whole topic. And my details are there. I'm happy for anyone to contact me afterwards. I can stick around now if we're not going to get kicked off. If anyone's got any questions, I'm happy to spend some time now answering them. But thank you all for listening.
If I can speak first, Rach, Rebecca.
Sure.
Thank you very much for hosting that session. It's really always our awareness of the radon situation in the UK and the measures that are available and to what needs to be done. If we have any questions from the floor, if you'd like to just raise your hand in the chat and pose the question to Rachel, the floor's open. Or if people like to speak accordingly, please feel free to speak and raise that question.
We've got a couple just sitting in the chat, actually. If I'll start with those, or people are thinking about whether they want to. One was saying, surely with a basement in a domestic setting, the tanking membrane, if properly installed, would act as a sufficient radon barrier? Question mark.
Not always, and it depends if we're talking about a membrane or a tanking slurry. So if you've got a cementitious waterproofing system on the wall, no, that is not necessarily, even if it is waterproof, it is not necessarily gas proof. And we have had buildings that we know are wet that would be wet if there were defects in that tanking cementitious system. The water would be coming through completely bone dry, and they've had very high levels of radon in. So again, what's waterproof is not necessarily gas proof. The problem with those sorts of systems though is that they are liable to shrinkage and cracking. As soon as you've got a crack, again, that won't help. If you're talking about a membrane like the type C cavity drain membrane that I was just talking about that we use, the problem with those is they are normally, unless it's been specifically designed to take account of ground gas as well, they normally leave ventilation gaps so you don't get condensation issues, condensation forming on that membrane. And so around the perimeter drainage, there's lugs to allow some natural ventilation. And what that can do is let the radon through. If you do have the membrane, so it is sealed at the perimeter, unfortunately, what it can do is funnel it up behind the membrane, so collect the gas behind the membrane, and then you end up with high radon levels at ground floor inadvertently. And we've had quite a few people come to us and they said, oh, we've had waterproofing contractors come in and we've got this nice new home office in the basement, but now we've created a radon problem upstairs that we never had before. So not necessarily, and it can often make it worse if you put a tanking system in or something without actually understanding what it's doing for radon as well.
Lovely, thank you. And then another one. So carry on, Steve.
I said there's a question here from Lee Jones. Is radon lighter than air?
Aha. So I always get asked that question. No. So radon itself, you would say, is a heavy gas. If you had a yogurt pot of radon and a yogurt pot of standard air, which obviously is a mixture of gases that we breathe and all sorts of things in the air, the pure radon would be heavier than the air that we normally breathe. But when it comes into a building, we have the stack effect, we have all air movement going on in a building. You don't get the radon down here and then the nice clean air up here. It all mixes together. And people often think, oh, is it collecting in the basement because it's sunk down because it's heavy? No, it's higher levels in the basement because that's where it's coming in through the ground. That's the entry point. So hopefully that answers that.
Okay, we've got some more questions here, if we may. People are okay online. What are the current exemptions for extensions? Does the old BRE guidance still apply?
So I believe that it depends on local authorities on extensions. Certainly when I've looked at this at the past, different local authorities have had different criteria on the size of the extension, if it's bigger than 5 meters square or 15 meters square or whatever it might be. So I can't give you a definitive answer on that. Check what it says in BR 211 and check with your local authority what their requirements are.
Okay, another question we have, how do these work in houses with MVHR?
So if you've got MVHR, you can probably use that system as a positive pressure system, it's all to do with balancing the airflow to make sure there's more air coming in than you're extracting. So you want to have a positive input rather than negative. If you're putting a sump system in, that's fine, that won't affect, but you can, if you've already got an MHVR system in, depending what your radon levels are, you may well be able to tweak the settings on that to give you the positive pressurization that you need.
Okay, another question I have is radon still an issue that NHBC certification is dependent upon?
So I certainly know a couple of years ago they would, they said they were guaranteeing it, the workmanship, and if you came with a high radon level afterwards, you could then claim the defect on it. I believe that is no longer the case. I don't know. I know NHBC are quite engaged. They came to the last, so I sit on the board of the UK Radon Association. They did send representatives to the last radon forum that we had. But I don't know whether they're requiring it for part of the certification or not, I'm afraid. I
would suggest that you refer that to either the NHBC or any other warranty provider that might be out there to answer that question for you. Maybe one last question, then we'll bring in, because I'm conscious of time for everybody.
Okay.
Would a 1200 gauge membrane suffice as a basic membrane protection for radon?
So again, this is, if you look back at BRE documents, certainly in the last document, they would say, 300 gauge polythene, this, that. If you were in laboratory situation, if you had some radon, again, in something like a yogurt pot, and you put a 1200 gauge membrane on top of it, in theory, the radon should not diffuse through that membrane. But on a building site, it's not just about this being this complete sheet of membrane and there's your radon there. The radon's coming through all through the site. You've got joints. Is it going to withstand the following trades walking over, having the concrete poured on it, last the lifetime of the building? So that it's more the issue of the durability of the membrane rather than does that stop the radon coming through. So yes, if you look at the guidance, yes, 1200 gauge polythene should be okay for radon barrier.
Thank you, Rebecca. I've actually had a response to the previous question.
Okay.
From a Mark Davis, who I suggest may work for NHBC. Mark is saying that the certification is only required if NHBC were the building control provider, not the warranty provider. So hopefully that answers people's questions on that one. I think at that point, we're going to call it a day. I can only thank you, Rebecca. That's been a fantastic CPD. I personally, at the tender age of 70, learned an awful lot about radon, and I hope everybody else has done so. And if I could just leave one final message, any West Midland members present, our next CPD will be in person on the 3rd of June. So watch this space and we'll be in touch and look to see you at the venue to be advised. And once again, on behalf of Kay, Rebecca, thank you so much. A really, really informative CPD. Thank you. And I'm sure that if people have personal questions, you're happy to receive emails. Is that correct?
Yes, please do. My email address is up there on the slides, or Rosemary's got my contact details, so she can put in touch. Please do contact me.
Thank you, everybody. Thank you for all attending. Thank you again, Rebecca. And
bye.
Thank you.